Next rule is the chain rule. The general form of the chain rule is if h of x equals g of f of x, then h prime of x equals g prime of original f of x times f prime of x. The way that I like to teach this is the outer function. What's happening, the outermost, is like the mommy with a baby inside of it. When you go to take the derivative, you take derivative of mommy with baby inside unchanged, and then derivative of baby. So to help us take these first three derivatives, we're going to identify first what's the outer function or the mommy function, what's the inner function or the baby function. So in this first one, 5x minus 2 is being taken to the 6th power. That means the outermost or mommy function is something being taken to the 6th power. The function that's inside of that is 5x minus 2. For the second equation in part B, we have the root of 3x squared minus 8x. The mommy equation is square root, or we like to see that as to the power of 1/2. The baby on the inside is 3x squared minus 8x. In part C, we have sine 7x cubed plus 4. The outer function is sine of something. The inner function is 7x cubed plus 4. When we now go to take each of these derivatives, we're going to follow through the formula. It says take the derivative of the outer function of the mommy function, leave the baby inside, and then multiply by the derivative of the baby. So the first mommy function is something to the 6th power. The derivative of something to the 6th power is 6, that same something, now to the 5th power. When I say something, it's really the unchanged baby as it was without any derivative being taken. Then we multiply that by derivative of baby. When we then simplify this slightly by saying 5 times 6, it ends up being 30, the quantity 5x minus 2 to the 5th power. For part B, we're starting out with something to the 1/2 power. It becomes 1/2, that same something, to the negative 1/2 power. In this case, that something was 3x squared minus 8x. And then we need to multiply by what was inside derivative. So 3x squared, the 2 comes down and makes it 6x. Negative 8x just becomes negative 8. Have to clean this up slightly. This 2 is already on the bottom because this is a negative exponent. This joins it. This stays on top. So this becomes 6x minus 8 over 2 the root of 3x squared minus 8x. Small thing, it's fine if you don't see it, but I can take a 2 out of everything. If I take a 2 out of the bottom and a 2 out of each term on top, I get 3x minus 4 on top, and on bottom I just get the root of 3x squared minus 8x. For part C, it's sine of something is the outer function. The derivative of sine is cosine of that same something, which was 7x cubed plus 4. Then we multiply by the derivative of the inside. In this case, 3 comes down. 3 times 7 is 21. Now x squared. When I multiply through, it becomes 21x squared. The cosine of 7x cubed plus 4. We also could combine different rules within each other. So it might be that as you're doing a quotient rule, there's a chain rule within it. It might be that as you're doing a product rule, there's a chain rule within it. These are examples of each of those. Here we start out with a quotient rule, 10 over 5x minus 6 to the power of 7. As we start to do this quotient rule, we do low, 5x minus 6 to the 7th. D high, derivative of a constant is 0, minus high, 10. When we go to do D low here, taking the derivative of the bottom is itself a chain rule. So we follow along with the chain rule and say, well, its outer function is something to the 7th power, inner function is 5x minus 6. So this becomes 5x minus 6 to the 6th power with the 7 out front. So I'm going to put the 7 out front, then 5x minus 6 to now the 6th power times the derivative of the inside, which in this case would be 5. All over, low, so we have to double the exponent that was below. So here it was 7. If we square that, it becomes 14th. So the bottom is 5x minus 6 to the 14th. Definitely can clean this up. Basically, I can take 6 of these out of everything. This term goes to 0, but here we've got 6 of them, here we've got 14 of them. So I'm going to cross out all 6 of these, reduce this by 6, down to 8. That means that my final form of f prime of x here is on top negative 10 times 35, which is negative 350. On bottom, 5x minus 6 to the 8th power. We also really could have gotten there by bringing this up and saying it's 5x minus 6 to the negative 7th power. This would all follow through and get to the same thing, but I wanted to show it as a quotient rule, and there definitely could be times where it can only be done as a quotient rule, especially if this would have had other variables with it or a combination of things. For part B, we're doing a product rule because this is the first thing being multiplied by this, the second thing. So we need to do the product rule as the derivative is first times derivative of second. First is x squared. When I go to do derivative of second, it's a chain rule. Outer function is third power. Its derivative is 3, comes down front. Same thing stays inside, 8x plus 7. Now to the second power. We took the derivative of the outside, leaving the inside the same. Now we need to multiply by the derivative of the inside, 8. When I clean this up, 8 times 3 is 24, times x squared gives me 24x squared out front, and then 8x plus 7, quantity squared trailing that. For 4a and b, we're going to take 2 derivatives. So we're finding the second derivative of this. The initial chain rule has the 5 on the outside that comes down. So it becomes h prime of x equals 5 unchanged 4 minus 3x. Now to the 4th power times derivative of the inside, which is negative 3. That really makes this negative 15, 4 minus 3x to the power of 4. When I take the second derivative, the 4 comes down, gets multiplied by the negative 15. Then I have the unchanged inside, 4 minus 3x, now to the power of 3, times the derivative of the inside, which is negative 3 again. Negative 3 times negative 15 is a positive 45, times 4 is a positive 180. So I get 180, 4 minus 3x to the power of 3. That is my second derivative that I've taken, so I can write it here as my answer. 180, 4 minus 3x to the power of 3. When I go to do the second derivative of this, because the inside here is something that will leave a variable expression, it's going to turn out that the first time I do chain rule, but the second time it looks a lot like part B above, where I end up with a product rule because I have some variable form of x times something that uses a chain rule. So the way that it looks is I take a first derivative. When I do that first derivative, this 6 comes down, leaves me with x cubed minus 2 on the inside to the 5th. Then when I multiply by the derivative of the inside, 3x squared, that's where the next step is going to turn into a product rule. The 3x squared gets multiplied by the 6 and gives me a total of 18x squared out front. Behind that, x cubed minus 2, now to the 5th power. When I take the second derivative, that's when the product rule appears. It tells me take first times derivative of second. Derivative of second is a chain rule. The chain rule says bring down the 5, keep the same thing, x cubed minus 2, now to the 4th power, times the derivative of the inside, 3x squared. I still need to add to this second times derivative of first. X cubed minus 2 to the 5th. Derivative of first here, the 2 comes down. 2 times 18 gives me 36. X squared. If I multiply what's on the outside here, this 3 times that 18 times that 5. So 3 times 5 is 15. 15 times 18 would be 270, I believe. Right? 30 times 9. Okay. So 270 x squared times x squared gives me x to the 4th. Then I still have this x cubed minus 2 term to the 4th power. Plus 36x squared times x cubed minus 2 to the 5th power. If I wanted to, I could factor out 4 of these x cubed minus 2's. I could factor out 36 that does go evenly into that, x squared. I'm going to leave it without factoring stuff like that out, just as it is written here. So my final answer is going to be 270 x to the 4th, x cubed minus 2 to the 4th, plus 36 x squared, x cubed minus 2 to the 5th.